Vivek, thanks so much for joining me on the podcast today.
You're welcome, Fabian. Thanks for inviting me.
You are an automotive researcher. You're currently a principal analyst at S&P Global, and before you've also worked with a number of other companies, including McKinsey as a researcher for 3.5 years. Let's talk a little bit about you first before we delve into the topic of today. What did your journey over the past couple of years look like?
Sure, Fabian. Yeah, I'm based out of Gurgaon near New Delhi, India. And for the major part of my professional journey, I've been working in the market intelligence, data, and consulting related jobs. Having graduated in the year 2000. I've spent my initial years as a quantitative data analyst, as you said, with McKinsey and Company in Gurgaon only. My stint with automotive basically started in 2011 when I joined IHS Global Insight as a senior automotive analyst. Since then, I've persisted with the company, which became IHS Markit in 2016, following its merger with British financial information and services company Markit, and eventually went on to become S&P Global in 2022. And I'm currently employed with S&P Global's mobility division as a principal automotive analyst, as you already mentioned. And I'm primarily responsible for developing technical and supplier-focused reports and other content around a diverse spectrum of technologies, with a particular focus on connected car, user interface and experience, vehicle autonomy, and PE and semiconductor practices, among others.
That's fascinating. Thanks so much for the overview, which leads me quite nicely to my first question around the automotive market more widely. What are some of the current trends that you see in terms of big trends, in terms of area of interest that you see with your clients or in the industry more widely?
That's a good question to begin, Fabian. I think the automotive industry is undergoing a period of unprecedented transformation, with the electrification, autonomous driving, and software-defined vehicle technologies. They're kind of reshaping the automotive landscape and have kind of placed a premium on innovation and efficiency. So artificial intelligence, and especially generative AI, generative artificial intelligence, has emerged as a powerful tool for automakers and suppliers alike. It helps them offer significant economic benefits and streamline product development processes. And which is fortunately precisely the focus of our discussion today as well. So yeah, I'm looking forward to this discussion.
You already alluded to some of the possible areas where automotive companies, so original equipment manufacturers, but also suppliers, potentially could deploy GenAI. What are some of the current discussions that you've seen around particular areas of interest and use cases for GenAI in the wider automotive context?
Right. Yeah, I think GenAI is really, spreading like wildfire. And I think before answering your question and going into the specifics, I guess we can do with a little GenAI introduction here.
Sure, let's do it.
Just for everyone's benefit. So generative artificial intelligence, or simply GenAI as we call it now, is an AI algorithm capable of generating text, images, audio, video, code, or any other data using generative models, often in response to prompts. So GenAI models learn the patterns and structure of their input training data and then generate new data that has similar characteristics. GenAI tools are usually built as an additional layer on top of large language models, or better known as LLMs, to streamline processes, enhance efficiency, automate software, sometimes improve performance metrics, and many other use cases. If I talk about my own experiences, there haven't been too many actually, but I would say that LLM-based experiences of ChatGPT in particular, and then Amazon Alexa, and some marketing chatbots in my previous work experiences have been quite interesting, to say the least.
You, of course, over the past couple of years have seen various trends. You just mentioned initially you're looking into connected cars, software-defined vehicle, which has been sort of a hype topic over the at least sort of previous decade. Autonomous driving, which I know I started working in automotive 10 years ago, and it's been always sort of going through phases, but it's always been sort of more advanced levels, at least 3 to 5 years ahead. Do you think Gen AI is sort of another, I guess, potentially overhyped topic at the moment that will sort of slowly but surely phase out and cool down in terms of the wider interest, or do you think that's something that is here to stay?
That's a great question, Fabian. I think it's definitely not going to phase out anytime soon. And the reasons are very simple. It has immense potential and a very quite varied use cases as well. Now, I really want to focus the discussion around automotive only. So if you look at carefully, Gen AI's journey so far, it's not a very old journey. Also, it's just begun. And if you see how Gen AI is evolving quickly in the automotive landscape, its potential to transform various aspects of the industry is immense. It spans significant improvements in efficiency. You talk about innovation, customization, and even customer experience. I would like to discuss, take up these one by one. So Gen AI, if you talk from a automotive perspective, it can be used to generate new vehicle design concepts, create virtual prototypes and optimize the manufacturing process. It can prove valuable for automotive dealerships even, who are looking to improve their customer engagement and lead generation. So it's Gen AI tools are useful for all the ecosystem, the entire automotive ecosystem, and all the stakeholders. Or if you speak about autonomous vehicles, merging Gen AI tools with autonomous vehicle technology can potentially fast track their decision-making capabilities for more informed and intelligent decisions. Automakers can assimilate chatbots into the car's interface to provide passengers with knowledge about the car's status and upcoming actions, which is crucial for autonomous vehicles. For instance, what alternate routes should the car take to avoid traffic congestion, or even identifying the nearest paid parking spot near a popular restaurant, say. So it's very useful. And again, coming back to car dealerships and manufacturers, they can leverage Gen AI tools to create conversational sales assistants that can guide customers through the buying process. Chatbots can form specialized recommendations based on the customer's preferences and needs. Automakers and part suppliers are using Gen AI technologies and tools to produce digital assistants that can help workers on assembly lines. These assistants can enact step-by-step instructions for assembling different components, like reducing errors and downtime, machine downtime, and maximize overall efficiency and productivity. Then next comes suppliers and logistic partners. By analyzing data from various suppliers and logistic partners, Gen AI can support automakers to optimize their supply chain and reduce costs as well. Then Gen AI models also have the potential to adapt to drivers' choices and preferences, like suggesting intelligent recommendations for navigation destinations and points of interest. Settings, adjusting the settings, for seats, mirror, climate, and audio settings. Then suggesting alternative routes, and creating personalized voice assistants for them as well. Lastly, I would say combining GenAI tools into the car's onboard computer, chatbots can also interpret diagnostic data and give recommendations for repairs or maintenance. So yeah, the uses are quite varied.
Sounds fascinating. And as you've sort of alluded to, it's quite a wide spectrum, essentially across the entire value chain and then also across the product and essentially the entire sort of user journey and experience. What are some of the use cases that you've seen original equipment manufacturers or suppliers to focus on right now, and what do you think sort of will be the next potential likely moves in terms of use cases they're going to explore?
I think suppliers are currently, from a GenAI perspective, are focusing pretty much on autonomous vehicle testing, and suppliers who are engaged in manufacturing of autonomous components that go into autonomous vehicles like radars and lidars and various sensors. They are leveraging GenAI tools quite a lot. So how they are doing it is like they are leveraging GenAI tools for creating detailed simulations that replicate real world conditions, and which allows them to carry on comprehensive testing of autonomous systems. These simulations can simulate various scenarios, from complex traffic situations to even adverse weather conditions, and which allows them obviously to the AI algorithm to learn and adapt in a risk-free setting. So there are no physical risks as such, real risks, and still they learn how to adapt in various scenarios. This not only reduces the time for the suppliers and OEMs and the cost associated with physical trials, but also allows them to continuously learn from driver behavior, allowing their systems to adapt accordingly. Then predictive maintenance is another use case which is really catching on quickly. So by analyzing patterns in vehicle data, GenAI tools help them forecast potential component failures, and allows proactive maintenance and preventing unexpected breakdowns and reducing overall downtime. Then suppliers and companies engaged in R&D, automotive R&D is also benefiting quite a lot from GenAI tools. So these tools are reshaping automotive research and development by accelerating new vehicle time to market. It helps them improve the quality and also fosters innovation throughout the organization. Companies are already investing heavily in GenAI applications to stay competitive. Then if you talk about customer experience, GenAI enhances advanced driver assistance systems, or ADAS systems, by processing information from sensors and cameras to provide real-time assistance to the drivers. Features like adaptive cruise control, lane keeping assistance, automated parking, these are all made ridiculously simple when you use GenAI tools and combine them with radars and lidars. Then highly upcoming domain is electric vehicles, electric mobility. In the electric vehicle value chain, GenAI tools are deeply embedded, influencing all stages from design to utilization, and helps in optimizing the entire life cycle of electric vehicles, so to speak. Then, as I already mentioned, personalized recommendations also are quite important. GenAI employs advanced data analytics to examine customer preferences, past interactions, and even purchasing behaviors of car buyers, and then generates personalized recommendations for customers as to what vehicle models are good for them what vehicle models should they buy, what features should they go for, what are the financing options available. And from a dealership perspective, they benefit from increased customer satisfaction and sales strategies also. I hope that answers your question.
No, that's fascinating. And it sounds like there is a lot of blue sky, a lot of hope, a lot of potential.
Absolutely.
What are some of the challenges that you see also from your experience in some of the other areas that you think some of these incumbents or large organizations across the automotive and mobility value chain have to overcome?
Technical challenges and solutions in implementing GenAI are many actually. I would say data security and privacy is one of the most crucial challenges here that companies encounter while implementing GenAI. As we know, GenAI models rely heavily on huge data sets to create accurate and meaningful outcomes. But when it comes to handling such huge and sensitive data, it can indeed privacy and security concerns. So companies have to be very careful here. Then training GenAI models requires substantial computational resources also, including high performance GPUs and significant memory. However, mid-sized or small businesses may encounter challenges in training and deploying these AI models due to restricted access to high performance computing resources, maybe because of financial constraints or even otherwise. And integrating GenAI technology with existing business processes and workflow can also be challenging and complicated as well, since it requires strong technical know-how and frequent modifications to enable the AI models to interact with the existing models. So yeah, challenges are many. But yeah, so far the industry is negotiating it well.
There are, of course, a couple of very prominent new players in this space and loads of the incumbent technology partners. To name a few, we've got Google, GCP, AWS, we've got Salesforce, we've got Atlassian,
Right.
and so many more that work on integrating GenAI into their existing product stack. Do you think that loads of the capability that is required will be in-sourced in terms of investments original equipment manufacturers and suppliers have to make internally to build up the GenAI capability more widely, data scientists, etc.? Or do you think this will be something, or what, depending on what you see already, where they tend to apply a little bit more flexible structures and work more with external partners to deploy some of the GenAI solutions?
That's a great point, Fabian. I think it's the industry is currently experimenting a lot with GenAI tools and procedures. So if I talk about specific examples or success stories, so to speak, of generative AI use currently in the industry, I would say vehicle designing is something that's at the forefront. We've seen how GenAI analyzes vast data sets and simulates design scenarios. It also helps generating multiple design options for complex automotive systems, including engines, lightweight structures, and vehicle features. This basically allows the designers to explore diverse possibilities. For example, generating lifelike 3D vehicle models from few parameters or sketches. This can accelerate the design process, in overall. It enables designers to visualize and refine their ideas faster and more efficiently. And if I talk about vehicle manufacturing, most players in GenAI currently have seamlessly integrated AI into all aspects of the car making process. So AI-powered systems enabling robots to adeptly pick parts from conveyor belts, autonomously discerning which parts to pick, how to pick them, and the appropriate sequence. This can reduce workforce requirements and enhance process accuracy also. It can create customized parts and components tailored to individual customer preferences and specifications. And then if you talk about GenAI's capability to analyze images and sensor data, and also detect and correct defects and anomalies in the production process, it it can lead to improved quality overall. So AI algorithms can help optimize engine performance, lessen emissions and improve fuel efficiency as well. So if you see the use of Gen AI tools is quite diverse, so to speak. If you talk about quality control, Gen AI tools are handy here as well. Gen AI tools, help companies analyze vast amounts of data and detect even subtle defects in manufactured parts. So the quality of already produced cars is something that can be really controlled using Gen AI tools. Even if you talk about the inspection process of already manufactured cars, Gen AI tools can help automate this. Not only improving the accuracy of defect detection, but can also significantly reduce the time and cost associated with manual quality control systems, right? Then Gen AI can also help transform supply chains, which is a huge use case again. It can assist in demand forecasting by analyzing historical data, market trends, and external factors. It can enable automakers to make more accurate production and inventory planning as well. It can optimize logistics and routing, minimize transportation costs and delivery times. I think we can go on and on, till the cows come home. If you talk about Gen AI use cases in the industry, we can go on and on. I think it's better if we focus on some real world examples now. If we talk about BMW, it has incorporated ChatGPT into its iDrive system, which is letting drivers control various functions of their cars using natural language voice commands. This may include features such as adjusting the temperature, changing the radio station, and even opening and closing the sunroof. Then if we talk about Tesla's autopilot system, it also uses AI algorithms, to enhance the performance of the cars in neural networks and reinforcement learning. Tesla also has its own version of an AI chatbot called Grok, which is currently in test mode. Then talking about Mercedes-Benz, it started an optional over-the-air beta program in the US last year for close to 1 million vehicles equipped with the MBUX infotainment system. And by adding ChatGPT, the brand has, the brand's voice control capabilities have become even more intuitive. And if I'm not wrong, Mercedes is planning to use the findings from this beta program to further improve its voice assistance and define the rollout strategy for large language models in more markets and languages. Besides this, Mercedes-Benz is also testing ChatGPT in production to accelerate the use of intelligent tools like in the MO360 digital production ecosystem. Talking about Toyota, the Toyota Research Institute recently introduced a Gen AI method utilizing what they call diffusion policy to basically teach robots new dexterous skills with an aim to create large behavior models, like the transformative large language models upon which conversational AI is built. So yeah, the industry is actually, a lot of things are going on simultaneously in the industry.
That's been a fascinating overview. Just two more questions from my side. One is
Sure.
potentially a little bit more of a personal one, given your role. How is Gen AI changing the landscape of automotive and mobility research, and how do you think this might evolve?
Again, a great question, Fabian. Regarding research activities, again, I would say, vehicle designing, prototyping, production, and it's Gen AI has really come a full circle. It has users in virtually every aspect of the automotive process, from production to sales to after sales. So if I talk about a particular, use case, let's talk about patent management, which is a big need up post research and development. So GenAI in this case can support various processes such as patent research, classification, patent landscape analysis, summarization, drafting assistance, and translation. This requires access to internal and external patent information, which GenAI tools are quite adapted to. Then the technological approach that GenAI models follow would include large language models, natural language processing methods such as concept mapping, topic modeling, and semantic search also. And you can also talk about in-car experiences. How GenAI is revolutionizing the in-car experience. So by analyzing user preferences, it can suggest music, podcasts, and audiobooks tailored to individual tastes. Imagine a system that learns your musical preferences, introduces you to new artists, and curates an audiobook playlist for your next road trip. It's quite exciting, isn't it? Then, if you talk about navigation, context-aware navigation is another application, where GenAI tools are quite handy. Instead of relying on traditional maps, GenAI can provide intelligent navigation on your driving habits and preferences. Then voice assistants, as I already mentioned, it's become a very common feature on our phones, which are becoming smarter in cars thanks to GenAI. Then on top of that, advanced driver assistance systems can offer superior situational awareness and predictive capabilities. It can analyze surroundings, identify potential hazards, and predict driver actions also. I think, yeah, that's where the industry is heading towards when you talk about GenAI use cases and applications.
That's fascinating. Thank you. Final question from my side. Imagine that you're talking to some of the leaders, whether at suppliers or manufacturers, that are in charge of the sort of data and GenAI strategy across the organization. Are there any learnings from some of the developments over the past sort of decade plus it relates to technological advancements that you think these leaders need to be aware of to make the most and unlock the full value of GenAI?
Sure. That's a great point, Fabian. At the end of the day, it depends on what use we are making of GenAI, because it's like an ocean. It really depends where you're diving. So if you want me to suggest to the automotive leaders where they should channelize their energies, I would say they must invest in understanding GenAI's capabilities first and evaluate its various benefits in a quite comprehensively. This may require identifying specific functions and use cases. OEMs should start with low risk and high demand use cases to understand the capabilities and limitations of language models within the automotive business context. Gradually, they can expand to more complex scenarios as they grow on confidence and experience. And many use cases, as I mentioned before, can be a good starting point, such as agent assistive capabilities for contact centers, knowledge management, and maybe content creation and translation as well. We know how several tools and platforms have integrated AI into their products, such as Salesforce, Einstein, and Microsoft 365 Copilot. But what we have found lately is that these tools do not achieve the full potential of GenAI. So it's very important for automakers and suppliers alike to select the right tools and platforms also. And organizations must also develop a comprehensive training program to upskill the workforce on GenAI technologies, simply because the skills required to activate an overall strategy do not exist at scale today. And last point I would think of is the company should adopt, the leaders who are responsible for implementing GenAI, they should concentrate on a collaborative approach, as GenAI is something that requires a truly diverse set of skills to be implemented successfully. And Organizations should collaborate with stakeholders such as customer and dealer representatives, data scientists, legal experts, and not just IT specialists. That's all I would say.
Thank you so much, Vivek. That's been a fascinating conversation. I definitely learned a lot from you today.
Thank you, Praveen. Thank you so much.